Okay, here we have what could be a very complicated question where we're going to look at the effect of shape on essentially a conductive material. This is again from B5, our current circuits. Have a look and then we'll give it a go. All right, so first thing to recognize the dimensions. We initially have a dimension of 1 this way. It's a cube, so we've got 1 in all the other dimensions as well. The volume here is 1 times 1 times 1, 1 centimeter cubed. The material is being reshaped, okay, into a block with a certain length and a constant cross section. So that's all fine. I think the thing to think about now is what are the bits that we can get rid of and what are the bits that we need to then consider here. So here what I'd advise you to think about is the relationship between resistance and the quantities being changed here. In our transformation from A to B, if you like, we are doing two things. One of them, we're making the resistance longer. Now resistance going longer, L going up, I've written here, R goes up. The resistance goes up with a longer resistor. You see this when you make resistors in series, we're making a longer resistor, higher resistance. At the same time, the area is going down. And what we mean here by the area is the area of this side here. We are measuring the potential difference across the opposite sides, okay? And so the area here is going to be smaller. So again, when we reduce the area, there's less space for the charge to move through, there's a higher resistance. Now in both cases, again, if we're thinking about exam technique, you can rule out some answers. We are expecting resistance to get higher. Well, if you notice here, we've got an original resistance of 50, 3.1 is definitely lower than 50, and 50 is the same as 50, so we're expecting these two answers to be wrong. So again, if you're running out of time, if you want to try and make your chances better of getting the answer right better, sometimes it's good to rule things out. Obviously, we'd love to know the answer. However, if you're running out of time, then it's good just to kind of sometimes work it out in this way. So we've got two options left. Let's see which one's right. Now, let's go with just what would happen if I made the resistance 4 times longer. Now, what you're going to get is, well, resistance is directly proportional to L. If L becomes 4 times longer, then R is going to also become 4 times bigger. And so if we started with 50, that 50 is going to become some R dash, which equals 200. Now notice that's not one of our answers. Okay, however, it's a possible thing, a possible answer there. There are two possible answers still remaining. We now need to think about the area change. Okay, well, if the length becomes 4 times bigger, the area is also going to become 4 times smaller. Why is that? Because the volume is constant. Volume is the product of area and length. If length goes up by a factor of 4, area goes down by a factor of 4, and so therefore our R gets increased by another factor of 4 because of that area change, and therefore it's going to end up being 800 ohms, which is why the answer here is C.